Greetings, citizens of the world. This is Anonymous. Over the last few years, images have surfaced from Yellowstone National Park that raise questions too significant to ignore. These photos show dramatic ground deformations, shifts in the earth that suggest immense forces are building beneath the surface. Entire landscapes appear to rise, as though the ground itself is swelling from pressures that remain unseen. Yet, despite the striking nature of these changes, Yellowstone's official researchers have remained curiously silent. Their lack of comment, their absence of acknowledgement, has only fueled suspicion among those paying attention. The silence is deafening. In a world where information is instant, where every tremor and quake can be tracked in real time, the withholding of details signals more than caution. If the public were shown the full scale of what is happening beneath Yellowstone, how would they react? Would panic spread, or would trust in institutions collapse? These questions alone may explain the silence. A supervolcano is not a matter of speculation. It is a geological fact. Its potential to disrupt life on this planet is immense. For years, officials have downplayed the risks, framing Yellowstone as stable, under control, harmless. Yet the images tell another story. They reveal that the land is shifting, rising, changing in ways that cannot be explained away as routine. We are Anonymous. Expect us.
Yellowstone National Park, renowned for its breathtaking landscapes and geothermal wonders, is now at the center of a potentially alarming geological development. Amateur researchers and avid watchers of the park's live cameras have observed a large bulge forming beneath the park, sparking concerns that a significant geological event may be brewing. A group of dedicated amateur researchers, who regularly monitor the live cameras set up around Yellowstone National Park, have reported a disturbing anomaly. These enthusiasts noticed the emergence of a dome-shaped bulge beneath the park's surface, a phenomenon that seemed to develop over several months. Intrigued and concerned, they began to systematically document and analyze the changes they observed. To substantiate their claims, the researchers collected and compared photographs from several months ago with more recent images. The comparison revealed a noticeable increase in the bulge's size and prominence. This evidence suggests that the ground beneath Yellowstone is rising, potentially due to magma accumulating in a subterranean chamber. The consistency and clarity of these photographic records have lent credibility to their observations. Yellowstone National Park sits atop one of the world's largest active volcanic systems. The Yellowstone caldera, often referred to as a supervolcano, has experienced 3 major eruptions in the past 2.1 million years, with the most recent occurring approximately 640,000 years ago. These eruptions were cataclysmic, significantly altering the landscape and impacting our planet. The Yellowstone volcanic system is continuously monitored by the United States Geological Survey and other scientific bodies. Regular seismic activity, hydrothermal explosions, and ground deformation are part of the region's dynamic geological environment. However, the formation of a large bulge suggests a more significant and potentially hazardous development. The most straightforward explanation for the bulge is the accumulation of magma beneath the park. As magma rises from deeper in the Earth's mantle, it can create a dome-shaped uplift on the surface. This process is not uncommon in volcanic regions and can precede eruptions. The photographs showing the increasing size of the bulge support this theory, indicating that a substantial amount of magma may be pooling in a subterranean chamber. Another possibility is that the bulge is the result of increased hydrothermal activity. Yellowstone is known for its extensive network of geysers, hot springs, and fumaroles, all of which are driven by the heat from the underlying magma. Changes in the hydrothermal system, such as the pressurization of underground water reservoirs, could also cause surface deformation. However, the dome-shaped structure and its steady growth suggest that magma accumulation is a more likely cause. The primary concern raised by the formation of the bulge is the possibility of an eruption. While Yellowstone's volcanic activity is closely monitored, predicting eruptions remains an inexact science. If the bulge indicates that a significant volume of magma is accumulating, the risk of an eruption could be increasing. An eruption at Yellowstone could range from a minor event, releasing ash and lava locally, to a catastrophic super-eruption with global consequences. An eruption at Yellowstone, particularly a large one, would have profound environmental and human impacts. Locally, it could devastate the park and surrounding areas, destroying habitats and communities. Ash fallout could disrupt air travel, damage infrastructure, and pose health risks across the continent. On a global scale, a super eruption could inject vast amounts of ash and sulfur dioxide into the atmosphere, leading to a volcanic winter with significant climatic and agricultural consequences. In response to these observations, increased monitoring and research are essential. The United States Geological Survey and other scientific institutions should enhance their surveillance of the region, employing tools such as satellite imagery, ground-based radar, and seismic sensors to gather more detailed data. Collaborative efforts between amateur researchers and professional scientists can also help validate and expand upon the initial findings. Raising public awareness about the potential risks associated with Yellowstone's volcanic activity is crucial. While it is important not to incite panic, providing accurate information about the current situation and potential scenarios can help communities prepare for any eventuality. Public education campaigns and emergency preparedness plans should be developed to ensure that people understand the risks and know how to respond in the event of an eruption. Recently, the park has experienced a swarm of earthquakes, drawing attention from scientists, tourists, and the general public. These seismic events have raised concerns about the stability of the Yellowstone caldera, often referred to as the Yellowstone Supervolcano, and they come just days after tourists at Yellowstone National Park managed to film the terrifying moment when a massive explosion occurred, causing them to flee in fear for their safety. The footage reveals numerous guests quickly evacuating a boardwalk located dangerously close to a scorching hot spring. Biscuit Basin has been completely closed off by the National Park Service as geologists conduct an investigation into the incident. This occurrence once again prompted speculation on the potential impact of these earthquakes on the national park. Some individuals who examined the data provided by the United States Geological Survey have noted the absence of certain portions. For instance, they reported that on certain days, only a few hours of the day were displayed, while the remainder was left unaccounted for. Consequently, certain individuals questioned whether certain information was being withheld. While the United States Geological Survey has acknowledged the occurrence of these minor tremors throughout Yellowstone National Park, some individuals are expressing greater concern about the occurrence of more significant earthquakes in the region. They question why these events have not been addressed by park authorities and media organizations. Graphs depicting Yellowstone indicate that the occurrence of these earthquakes had observable consequences on the park, since there was evidence of magma movement. There is another earthquake that has not been reported, which had a magnitude of 2.4. The graphs indicated a seismic event of greater magnitude than usual that occurred in the region, but no information or communication was provided regarding this occurrence. Upon the dissemination of the photographs, individuals began to inquire as to why this information was being withheld. There are hypotheses suggesting that the reason for not disclosing information could be to prevent causing anxiety among the public. Alternatively, others speculate that there might be ongoing events in the Yellowstone area that authorities are aware of but choose not to disclose. Dr. Poland stated that the earthquakes that have been observed are within the expected range of normal activity. The Yellowstone system exhibits high levels of tectonic activity, resulting in an average of around 1,500 to 2,500 earthquakes each year in the surrounding area. Typically, Yellowstone experiences between 100 and 200 earthquakes every month, primarily resulting from minor faults. The convergence of a fragile crust, elevated temperatures, numerous faults, and active subsurface water movement generates optimal circumstances for the occurrence of several smaller earthquakes. Scientists have recently stated that the animals residing in Yellowstone National Park have been engaging in migration. According to certain studies, animals have the ability to detect variations in electrical fields or the discharge of gases from the Earth. This is why some animals seek refuge when an earthquake is imminent. In the last 2 years, this supervolcano has demonstrated to scientists its ongoing activity. Researchers said that last year, 2 out of the 3 indicators signaling an imminent eruption were detected. These indicators consist of a rise in seismic activity and an escalation in the number of gas vents on the surface. In addition to this, researchers at the park have reported the emergence of new erupting vents and surface fissures, They have been compelled to shut down a boardwalk in the well-liked upper basin. Currently, researchers are monitoring the activity closely. Due to its potential for catastrophic eruptions, the supervolcano is under constant surveillance by scientists and governmental agencies. While the likelihood of another super eruption occurring in the near future is low, the potential consequences of such an event are immense. A super eruption could spew thousands of cubic kilometers of ash and pyroclastic material into the atmosphere, significantly impacting global climate, agriculture, and human health. Even smaller eruptions or hydrothermal explosions within the caldera could pose significant risks to the park and surrounding areas. The primary reason for monitoring the Yellowstone supervolcano is to protect public safety. Surveillance of the supervolcano also advances scientific understanding of volcanic processes and hazards. Yellowstone is a unique natural laboratory for studying geothermal and volcanic activity. By monitoring the volcano, scientists gain insights into the mechanics of caldera systems, magma movement, and the triggers of volcanic eruptions. This knowledge not only enhances our understanding of Yellowstone, but also improves our ability to predict and prepare for volcanic events worldwide. One of the primary tools for monitoring the Yellowstone supervolcano is seismic monitoring. The Yellowstone Seismic Network, operated by the United States Geological Survey and the University of Utah, consists of over 50 seismometers distributed throughout the park. These instruments detect and record earthquake activity, providing data on the movement of magma and geothermal fluids beneath the surface. Increased seismic activity can indicate changes in the volcanic system and potential precursors to eruptions. Scientists also monitor ground deformation to detect changes in the shape of the Earth's surface caused by magma movement. The Yellowstone Volcano Observatory employs a combination of GPS stations, satellite-based interferometric synthetic aperture radar, and borehole strain meters to measure ground deformation with high precision. Uplift or subsidence of the ground can signal changes in magma pressure and movement, helping to assess the likelihood of volcanic activity. Geochemical monitoring involves analyzing the composition of gases and thermal waters at Yellowstone's geothermal features. The release of gases such as carbon dioxide, sulfur dioxide, and hydrogen sulfide can provide clues about magma movement and volcanic activity. By sampling and analyzing these gases, scientists can identify changes in the volcanic system and assess the potential for eruptions. Remote sensing technology, including satellite imagery and aerial surveys, plays a crucial role in monitoring Yellowstone's supervolcano. Satellites equipped with thermal imaging and spectrometers can detect changes in surface temperatures and gas emissions. The continuous monitoring of Yellowstone's supervolcano is integral to developing and maintaining early warning systems. By detecting signs of increased volcanic activity, scientists can provide timely alerts to governmental agencies and the public, allowing for preparedness measures and potentially saving lives. Effective communication and coordination among federal, state, and local authorities are essential to respond swiftly to volcanic threats. Surveillance data informs preparedness and mitigation strategies for potential volcanic hazards. Emergency response plans, public education campaigns, and infrastructure resilience measures are all based on the insights gained from monitoring the volcano. By understanding the risks and preparing accordingly, communities can reduce the impact of volcanic events on lives and property. Researchers have uncovered a previously unidentified source of partially liquefied rock that is large enough to fill the Grand Canyon 11 times over. The researchers employed seismic tomography to provide a comprehensive depiction of the entire volcanic plumbing system in Yellowstone, spanning from the Earth's mantle to the surface. Yellowstone National Park showcases a diverse range of geothermal phenomena such as geysers, mudpots, steam vents, and hot springs. This park is situated on top of a supervolcano that has had 3 catastrophic eruptions. Prior to this discovery, scientists were previously aware of the existence of a substantial magma chamber beneath Yellowstone National Park. This chamber was responsible for supplying the volcanic eruptions that occurred approximately 2 million, 1.2 million, and 640,000 years ago. The recent research, published in the prestigious journal Science, unveiled a further, more profound reservoir that is 4.5 times greater in size. The presence of a second magma chamber does not affect the likelihood of a major volcanic eruption at Yellowstone. According to seismologist Jamie Farrell from the University of Utah, these findings have little impact on the existing volcanic danger at Yellowstone. Nevertheless, these recent discoveries do furnish us, as well as other scientists, with the necessary information to enhance our comprehension of the process by which magma migrates from the Earth's mantle to the surface. According to Professor Fan-Chi Lin, a geology and geophysics professor at the University of Utah, there is a blob-shaped magma reservoir in the lower crust of the Earth underneath Yellowstone. This reservoir is located at a depth of 12 to 28 miles, or 19 to 45 kilometers, and has a volume of 11,500 cubic miles, which is over 11 times larger than the volume of Arizona's Grand Canyon. The magma chamber is composed of predominantly solid and porous rock, interspersed with pockets of molten rock. The researchers reported that approximately 2% of it was entirely liquefied. The upper and lower magma chambers are located above a geological phenomenon known as a plume or upwelling. This plume originates from the Earth's mantle, approximately 40 miles below the surface, and transports hot materials towards the surface. Scientists have previously hypothesized the presence of a subterranean reservoir of molten rock, known as a magma chamber, but were unable to definitively verify its existence. The researchers employed seismic tomography, a method akin to a CT scan, to visualize the subsurface by utilizing seismic waves that traverse the Earth. This technique enables the differentiation of rocks with different densities. In addition, they used local and remote earthquake measurements to visualize the entirety of Yellowstone's magma system. Earthquake swarms are sequences of seismic events that occur in a localized area over a short period of time, without a single dominant main shock. Unlike typical earthquake sequences, which consist of a main shock followed by aftershocks, swarms are characterized by numerous small to moderate-sized earthquakes. These swarms can last from hours to weeks and may vary in intensity and frequency. Yellowstone National Park has a long history of seismic activity, with thousands of earthquakes occurring each year. Most of these are minor and go unnoticed by the public. However, the park has experienced several notable earthquake swarms in the past, such as the 1985 swarm near Lake Hebgen and the 2008 swarm near Yellowstone Lake. These events have provided valuable data for understanding the geological processes at play in the region. The recent swarm of earthquakes in Yellowstone has captured widespread attention due to its intensity and duration. Beginning in late 2021 and continuing into 2022, the swarm has included hundreds of small to moderate-sized earthquakes, with magnitudes ranging from 1 to 4.5. The epicenters of these quakes are concentrated in the western part of the park, near the Norris Geyser Basin and the Yellowstone Caldera. The United States Geological Survey and the Yellowstone Volcano Observatory have been closely monitoring the swarm using a network of seismometers and other geophysical instruments. These tools provide real-time data on earthquake locations, depths, and magnitudes, allowing scientists to analyze patterns and assess potential hazards. The data collected during the swarm is crucial for understanding the underlying geological processes and for forecasting future activity. Yellowstone's earthquake swarms are primarily driven by the region's tectonic and volcanic activity. The park sits atop a hotspot, where a plume of hot mantle material rises towards the surface, causing the Earth's crust to stretch and thin. This process creates faults and fractures in the crust, which can lead to earthquakes when stress is released along these faults. In addition to tectonic forces, the movement of magma and hydrothermal fluids beneath the surface can also trigger earthquakes. As magma rises and exerts pressure on surrounding rocks, it can cause fracturing and seismic activity. Similarly, the movement of hot water and steam through the park's extensive hydrothermal system can induce earthquakes by altering the pressure and stress conditions in the crust. One of the primary concerns associated with earthquake swarms in Yellowstone is the potential for volcanic eruptions. While swarms can be a precursor to volcanic activity, it is important to note that the majority of swarms do not lead to eruptions. The United States Geological Survey and the Yellowstone Volcano Observatory closely monitor changes in seismicity, ground deformation, and gas emissions to assess the likelihood of an eruption. Based on current data, there is no indication that the recent swarm is leading to an imminent volcanic event. The recent earthquake swarm underscores the importance of public safety and preparedness in regions with significant geological activity. Residents and visitors to Yellowstone should be aware of earthquake risks and follow guidelines for earthquake safety. This includes securing heavy objects, having emergency supplies on hand, and knowing how to respond during and after an earthquake. The United States Geological Survey and the Yellowstone Volcano Observatory offer valuable resources and updates to help the public stay informed and prepared. The data collected during earthquake swarms in Yellowstone contributes to the broader understanding of volcanic and seismic processes. By studying these events, scientists can gain insights into the behavior of magma, the mechanics of faulting, and the dynamics of geothermal systems. This research not only enhances our knowledge of Yellowstone, but also informs the study of other volcanic and tectonic regions around the world. The Yellowstone Supervolcano is one of the most powerful and potentially destructive volcanic systems on Earth. Its past eruptions, the last of which occurred approximately 640,000 years ago, have reshaped the landscape and had far-reaching impacts. If the Yellowstone supervolcano were to erupt again, the consequences could be catastrophic, with significant damage on local, national, and global scales. The most immediate and severe damage from a Yellowstone supervolcano eruption would occur within the vicinity of the caldera. The eruption would likely begin with massive explosions that could eject thousands of cubic kilometers of volcanic material into the atmosphere. The force of these explosions could destroy everything within a 50 to 100 kilometer radius, including the park's infrastructure, wildlife, and any human presence. The pyroclastic flows, fast-moving currents of hot gas and volcanic matter, would incinerate and bury everything in their path, creating a lifeless landscape reminiscent of past eruptions. Beyond the immediate vicinity, the eruption would produce a colossal ash plume that could extend hundreds of kilometers. The ashfall would blanket large areas, potentially covering states such as Wyoming, Montana, Idaho, and beyond, with several inches of ash. This would cause severe damage to buildings, infrastructure, and agriculture. Roofs could collapse under the weight of the ash, roads and airports would become impassable, and crops could be destroyed, leading to food shortages. The ash would also pose significant health risks. Fine volcanic ash particles can cause respiratory problems, especially for those with pre-existing conditions. The air quality would deteriorate drastically, necessitating the use of masks and air filtration systems to prevent widespread respiratory illnesses. One of the most profound effects of a Yellowstone supervolcano eruption would be its impact on our planet. The eruption would inject vast amounts of sulfur dioxide and other aerosols into the stratosphere, forming sulfate aerosols that reflect sunlight and cool the Earth's surface. This phenomenon, known as a volcanic winter, could lead to a significant drop in global temperatures for several years. A prolonged volcanic winter caused by a Yellowstone eruption could lead to shortened growing seasons, reduced agricultural yields, and widespread food shortages, exacerbating the humanitarian crisis. The environmental impact would extend beyond climate effects. The ashfall and changes in temperature would disrupt ecosystems, affecting plant and animal life. Aquatic ecosystems would suffer as ash and volcanic chemicals enter water bodies, impacting water quality and aquatic species. The long-term ecological consequences could include shifts in species distributions and the loss of biodiversity. The economic damage from a Yellowstone supervolcano eruption would be staggering. The destruction of infrastructure in the immediate vicinity would require massive investment for rebuilding. Transportation networks, including roads, railways, and airports, would be heavily affected, disrupting trade and mobility. Agriculture would suffer severely from the ashfall and climate impacts. Crop failures and livestock expirations would lead to food shortages and increased prices, impacting both local economies and global food markets. The disruption of agricultural production could trigger a cascade of economic challenges, including inflation and reduced economic growth. The combined effects of infrastructure damage, food shortages, and economic disruption would likely result in a large-scale humanitarian crisis. Populations in affected areas might face displacement, requiring emergency relief and long-term recovery efforts. The strain on resources could lead to social unrest and political instability, particularly in regions heavily dependent on affected areas for food and trade. The global interconnectedness of today's world means that the repercussions of a Yellowstone eruption would not be confined to the United States. The climatic effects would affect weather patterns worldwide, influencing agricultural production and food security globally. International trade would be disrupted by transportation challenges and economic instability. The need for coordinated international response efforts would be paramount to manage the widespread impact effectively. As of right now, the potential eruption of the Yellowstone Supervolcano represents one of the most significant natural threats to human civilization. The immediate devastation would include massive loss of life and destruction of infrastructure, while the environmental and climatic effects would have profound long-term consequences. The economic impact would be severe, affecting not only the United States, but the global economy as well.